Have you ever wondered how an engineer knows exactly what size air conditioner your office needs? I mean, it's not just a guess, it's science. And today we are pulling back the curtain and breaking down exactly how they do it. We're diving into the heat load calculation. Okay, so the best way to think about this is to imagine your home, or any building, has a kind of heat budget. All day long, heat is coming in, those are the gains, and heat is also finding ways to escape, those are your losses. The whole job of your HVAC system is just to keep that budget perfectly balanced right where you want it. And that's the big question, right? To figure out that balance sheet, engineers have to become detectives, basically. They have to hunt down every single possible source of heat, big or small. So, let's start our little investigation. We're going to take a tour of all the surprising places heat actually comes from. And trust me, some of these might actually shock you. Now, this right here is super interesting because it shows that we're not just talking about the sun, blasting through a window. Look a little closer. You've got the lights, the computer, even the person just sitting there. They're all acting like tiny space heaters, constantly adding to the room's total heat. And wow, the list of these heat culprits, it's pretty long. You've got the obvious ones, for sure, like the sun beating down on the roof and walls. But then you have all these sneaky ones. The heat coming off our own bodies, our gadgets, and even all the little air leaks around doors and windows. That's called infiltration. So you see, keeping a room cool is a battle fought on a whole bunch of fronts. With all these different sources, it can seem like total chaos. So to get a handle on it all, engineers do something really smart. They group everything into two main categories, and that makes this whole problem way easier to solve. And this flowchart shows you exactly how they do it. The total load, that's all the heat your AC has to deal with, is just the sum of two things. External loads, which is all the heat trying to get in from the outside, and internal loads, which is all the heat being created inside. Simple as that. Think of external loads as a battle at the gates. This is all about how good your building's armor is. Its walls, its roof, its windows. The better your insulation, the better it fights off that heat from the outside, and the lower your external load is. And then you've got the internal loads. That's the heat we make just by, living and working. A packed conference room, for instance, has a way higher internal load than an empty one, just from all the body heat everyone in there is giving off. Okay, but here's where it gets even more interesting. Because it turns out, not all heat is created equal. It's not enough to just know how much heat there is, you also have to know what kind of heat it is. And this is absolutely critical. Your air conditioner is basically fighting two different battles at the same time. It has to lower the sensible heat, that's the actual temperature on the thermometer, but it also has to remove the latent heat. That's the hidden energy that's tied up in the humidity in the air. It's why we say it's not the heat, it's the humidity. So, the big question is, how do you turn all these ideas into actual numbers? Well, let's take a peek behind the curtain at the basic code engineers use to figure out just how much heat is coming through something like a wall. It all starts with this beautiful, simple little formula. Now, don't worry, don't let the letters scare you. We're not about to do a big math problem. We're just going to unpack the story this little equation is telling us about how heat gets from point A to point B. See, each piece tells a really simple story. Q, that's the total heat we're looking for. That depends on U, which is just about the wall's material. Is it thick brick or thin glass? Then there's A, the size of the wall. Obviously, a bigger wall lets in more heat. And finally, delta T, the temperature difference. The hotter it is outside, the harder that heat is trying to push its way inside. But here's the thing. The real world is a lot messier than a simple formula, right? The sun isn't just a lamp that stays in one spot. It moves across the sky. And summer in Alaska is very, very different from summer in Arizona. So this is where the simple formula gets a really clever upgrade. To make the calculations super accurate, engineers add these awesome little tweaks called correction factors. There's one for the time of day, because morning sun is different than afternoon sun. There's another one for your location in the month. And there's even one that adjusts for the color of your wall, because a dark wall soaks up way more heat than a light one. And this little table shows you exactly why this stuff matters so much. Check this out. At 9 in the morning, an east-facing wall is getting blasted by the sun, so it has a heat factor of 10. But the north-facing wall, it's still in the shade, so its factor is only 6. See? Direction matters, time of day matters, it all counts. Okay, I know, that was a lot of physics. But let's bring it all back to what really matters, your thermostat, your wallet, and your comfort. Why go through all this trouble? Because getting this calculation right, really right, has some huge payoffs. It's how you make sure your AC unit is the perfect size. Not too big, not too small. And that means it runs efficiently,
which directly lowers your energy bills. And hey, it reduces your environmental footprint. This is step one to creating a space that's actually comfortable and sustainable. And make no mistake, this isn't just theory. It's like the Goldilocks principle for your AC. If it's undersized, it runs and runs but can never keep up. If it's oversized, it's constantly kicking on and off, which wastes a ton of energy and doesn't manage the humidity properly. Finding that just right spot is everything.
So, now that you're in on the secret, take a look around you right now. What do you think is the biggest source of heat in the room you're in? Is it the window? The laptop you're using? Or maybe is it you? This hidden science is happening all around us all the time. The answer